We're using Sklearn's ARDRegression model for regression, and I've noticed some large ALPHA values, much larger than 1000. I'm trying to understand what this means about the model and the data. Let's figure this out. This is a possibility, but it is not the most likely explanation given the nature of ARD. This is a key insight. Large ALPHA values point to features with small variances, meaning the model is confident their coefficients are near zero, implying little predictive value. This statement is essentially the same as B, just phrased differently. The model effectively ignores these features by assigning them weights very close to zero. While multicollinearity can be an issue, large ALPHA values are not a direct indicator of it. Let's focus on what ALPHA directly tells us. I'm analyzing a scikit-learn model called ARDRegression, which is used for regression tasks. It's a Bayesian approach that automatically figures out which features are important for making predictions. The model has produced alpha values, which represent how much we trust the importance of each feature. For some features these values are much higher than 1000. This is the core of what we will understand. I'm trying to figure out what large alpha values mean for those features. Large alpha means that the model believes the coefficient is close to zero and this feature is not important in making predictions. It means high precision and low variance. I'm analyzing the output of the scikit-learn ARDRegression model, specifically focusing on the interpretation of the alpha values. ARD stands for Automatic Relevance Determination. It's a Bayesian method for feature selection. This is the core problem. We're given a regression model's output and asked to interpret it. We have large alpha values, and we need to determine what this means about the model and features. A large alpha value means a high precision for the coefficient. The model believes that the coefficient is very close to zero. That indicates the feature it corresponds to is not useful in predictions. This statement is very similar to B. If a feature has little predictive power, its weight will be close to zero, and it's like the model has ignored that irrelevant feature. While multicollinearity is a problem, where features are highly correlated, large alpha values don't directly imply it. They suggest the model believes that some features aren't important for prediction. Let's focus on the core meaning of alpha values. Overfitting is less likely because ARD's regularization usually prevents it. ARD tries to reduce the impact of features that are less important. I'm analyzing an ARDRegression model, a type of regression model that uses a technique called automatic relevance determination. This technique helps determine which features, inputs, are actually important for making accurate predictions. I'm working with a dataset that has 10 different features that might influence the thing I'm trying to predict. I'm using the ARDRegression model from the scikit-learn library in Python. Scikit-learn is a popular library for machine learning. I've trained or fitted the model to my data. This means I've let the model learn the relationships between the features and what I'm trying to predict. The model provides me with an alpha underscore attribute which gives me a measure of how precisely the model has estimated the importance of each feature. A higher value means more precision. I've noticed that some of the alpha underscore values are very large, specifically greater than 1000. This means for those features, the model is very certain about their low importance. I need to figure out what these large alpha underscore values mean in terms of the model's performance and the features. Given those high alpha underscore values, I have to determine which statements correctly describe what's going on. One possibility is that the model has learned the training data too well and won't generalize well to new data. Another possibility is that those features with large alpha underscore values are not useful for prediction. Perhaps the model correctly found that certain features are unimportant, effectively ignoring them in the prediction process. Maybe the problem is with the data itself, like having features that are highly correlated. This is called multicollinearity. I'm analyzing the output of an ARDRegression model, specifically focusing on the alpha values which represent the precisions of the coefficients. This is a crucial step in understanding how the model assigns importance to different features. We've fitted an ARDRegression model and are investigating its alpha values to interpret how it's assessing the importance of the 10 features used for prediction. Large alpha values suggest something specific about those features. My interpretation of a large alpha value is that the corresponding feature probably isn't very helpful in making accurate predictions. The model is effectively saying, this feature isn't very useful. This option reinforces the previous point. By assigning a large alpha, the model is essentially giving a negligible weight to that feature, effectively ignoring its impact on the prediction. I see this as a sign that the model has done its job of filtering out less impactful data. While multicollinearity, multicollinearity, can affect model results, I wouldn't directly blame the large alpha values on this. It's more likely that these large alphas reflect a feature's lack of predictive ability rather than a problem inherent to the dataset's structure. This is the specific value of alpha. The fact that it's much greater than 1000 strongly indicates that the model believes the corresponding coefficient is very close to zero, meaning that feature is not important. I interpret ARDRegression, a type of Bayesian linear regression, as a method that automatically figures out which features matter most in a dataset. It does this by assigning a precision, how certain we are about a feature's importance, to each feature's weight. A higher precision means I am very certain that a feature's weight is near zero, suggesting it isn't very important. These large alpha values in the context of ARDRegression are really important. Each alpha value represents the precision of a feature's coefficient, how much it influences the prediction. A large alpha means I have high confidence that the coefficient is very close to zero. Therefore, that particular feature probably doesn't contribute much to the prediction. High precision means I'm confident that the estimated value of a coefficient is accurate. In ARDRegression, a high precision for a feature's coefficient signifies that the model believes that the feature has little to no influence on the outcome, and the coefficient is very close to zero. A coefficient close to zero indicates that the corresponding feature barely impacts the outcome. In simpler terms, the feature doesn't contribute much to the model's predictions. Think of it like a tiny ingredient in a recipe. Its effect is barely noticeable. This question is about interpreting the results of an ARDRegression model, which is a sophisticated machine learning technique used to identify the importance of features in a dataset. The question focuses specifically on interpreting high alpha values. Overfitting is the opposite of what large alpha values show in ARDRegression. A model which overfits learns the training data too well, performing poorly on new, unseen data. Since large alpha values indicate the model is shrinking the influence of irrelevant features, overfitting becomes less likely. This is one of the correct answers. Large alpha values directly indicate that the corresponding features probably don't help much in making accurate predictions. This is also correct, and pretty much says the same thing as option B. The model implicitly gives these features almost zero weight in its predictions. Multicollinearity, features being highly correlated, can sometimes create issues in modeling, but large alpha values in ARDRegression are not a direct sign of this problem. The large alpha values themselves tell us that the model found many features to be unimportant. I see this as the core of the problem. We're using automatic relevance determination, ARD, a Bayesian method that automatically figures out which features are important for prediction. Think of it like a smart detective sifting through clues. ARD helps us identify the truly relevant features, discarding the noise. The question sets up a scenario where I am using scikit-learn's ARDRegression, a tool for regression analysis that uses a fancy Bayesian approach. The key is understanding that we have a model that has already been trained on a dataset with 10 features. These values are the clue. In ARD, the alpha values tell us how much we trust each feature's weight. A high alpha means we're very confident the feature's effect is close to zero, it's essentially irrelevant. A value greater than 1000 strongly suggests the corresponding feature is not useful for prediction. This is the central theme, understanding what those large alphas mean. We're not just looking at numbers, we're interpreting them in the context of ARD, which is all about automatically figuring out which features are actually useful. It's like a detective highlighting only the important clues. This is a common issue in machine learning, where your model learns the training data too well and doesn't generalize well to new data. But with ARD, we are less likely to overfit because the method shrinks the weights of unimportant features. It's a built-in safeguard against overfitting. This is a key takeaway. Large alpha values directly mean the model is downplaying these features. It's saying, these don't matter much for making accurate predictions. This is the same idea as option B, just phrased differently. The large alpha values showcase the model's ability to automatically weed out the unimportant features. Multicollinearity happens when your features are highly correlated, like having two similar clues in your detective case. While it could cause problems, large alpha values by themselves aren't a direct sign of multicollinearity. It's more indicative of the model deciding some features are not helpful,